And you see A and O combined with this a smile face. So this is our logo, okay? And then let me introduce myself. Uh, Currently, I'm 45 years old, and I have been working in surgical robot over 20 years. And this is my doctoral research, part of my doctoral research. And since this year, I founded our company and want to make my research project into a real product. So you see, China is a very, very big population country. In rural and in big city, the operation level is quite different. So we hope, according to the assistant of robot, a freshman can make make surgery more precise, efficient, safe, remote control, and minimally invasive. So you see, I have been working in several orthopedic surgery robots, such as orthopedic surgery, neurosurgery, and dental implant surgery robot. The dental implant robot is quite different with other. It's a local anesthetic surgery. So the patient are clear. He knows everything. And the dentist need to be trained for a long time from a freshman to expert. And this is so the patient nervous, feel pain, and expensive. We hope the dental implant robot can help to solve all kinds of problems. So you see, this is a freehand operation. Freehand operation is free, but the accuracy depends on dentist's personal experience. Mhm. Also, the surgeons feel uncomfortable and working all day like this in China. And the second option is digital hard guide plate. So in CBCT, we can planning the implant position and orientation, and then generate 3D print such kind of plate. This can be precise, minimally invasive, and easy to learn, especially for beginners. But if we said freehand is free, but not accurate, the digital hard guide is accurate, but not so free. If we think this direction is not so good, I want to change the direction, it cannot. And also it will influence the cooling effect. So the third option is navigation. You see, this is a mobile phone. How can we do navigation for driving? Because this mobile phone will tell satellite where it is. It's moved. But the building, some stable on the ground will tell the satellite where they are. So when we fixing a marker on the jawbone, it will be keeps stable. So when this camera watching this part, he will know where the bone is. On the handpiece, we also have other marker. With tracking this marker, the system can know where the drill is. So between the relationship of these two things, we can find the drill in jawbone's position and orientation. This is navigation. Navigation have solved the free and the accurate problem, both. But they have two questions, two issues. One is, you see, as a surgeon, we generally watching at the mouse, but in navigation, you have to watching the screen. And secondly, you see, the dentist drags the leaves, drilling, water irrigating, and the nurse will help to do suction, right? But if you use a navigation, you still need a technician to control the computer. So it needs extra human cost. So now I'm coming. The final solution is robot. We have been researched this robot for nearly over 12 years. Firstly, this is a university research project, and then we do animal clinical trial, and then do real patient clinical trial, and then after BBC and Chinese CCTV broadcast us, some investor raise money for our company, and then we want to make this product, this project into a real product. After 3 years, we have overcome the COVID-19 long period of COVID-19, and in this year, we got Chinese FDA certification. So at that year, after that, we started our commercialize in China. And you see, this is our robot outlooking, and this is our logo. This one, this two part was designed by a very good designer who have designed the Winter Olympic gold medal in 2022 in Beijing. Mhm. For surgeons, you always control the foot pedal to control drilling and water irrigating, right? So we also need a foot pedal to control the robot moving. Thus, we integrate an implant motor device inside of a robot. This foot pedal could not only control the arm moving, but also can control the drilling, water irrigating. And this is the world first autonomous dental implant robot. So, autonomous, the surgeon's hand feeling is very, very important. So we integrate a high precision force sensor in the end of the robot, which can feedback force and torque during drilling. And infrared vision watching the area, and we can do operation watching at the screen. So a lot of media, foreign and domestic media have reported us. You can Google Yakbot dental implant robot, and you also can see a lot of clinical cases. So this is reported by Chinese CCTV. This is reported by BBC. This is the original broadcast that in model. I will show you some real clinic cases. So this is a ceremony when we finished 100 cases in the year of 2021. You see, in our robot, we have divided the implant procedure into 3 steps: preoperative planning, intraoperative operation, and post-operative evaluation. You see, currently, China, old man became more and more, and young person less and less. I'm not sure whether in other countries it is the same situation. So, as a freshman, we hope this robot can enlarge the expert's working period, and also can help a freshman to be an expert as soon as possible. In our software, we have patient information management system, planning part, navigation part, and evaluation part. For our hardware part, we have a robot trolley, navigation trolley, and some accessories. So this is a totally digital clinic for our robot. Before the operation, we need to import CBCT data. You see, we have 3 parts. In planning part, we can do analysis for bone density wise, and then we can import oral scan data. Oral scan data can show surface very clear. Then we need to register these two data together. Currently, we have our AI segmentation, which can segment teeth besides the soft tissue in 1 minute. So in CBCT data, our AI module engine can segment upper and lower jawbones, sinus, teeth, nerve, and then these two data can register together automatically. And then we also have a module to plan the crown. After that, we plan the position and orientation of the implant. You see, a lot of implant systems have been integrated in our software. On the other hand, we still need to planning the drilling steps. For each drill, we need to drill planning the start point, end point, and the drilling speed. Of course, if the AI cannot give you a very good result, you also can modify it according to your experience. The most interesting part will come in. You see, this is a guide plate. Ask a patient to open his or her mouth. This is a mouth opener. And then we also release the surgeon's left hand. We also can add a lip retractor to drag lips and delete some unuseful parts. And then the nurse will do suction. We can add a tube to do the same mechanism automatically. You see, in the buccal or lingual side, there is a tube. We can make some holes. The buccal and the lingual sides, water, saliva, blood can all be absorbed by this tube. Please be seated, okay? So you see, all this software is also developed by our team. And then this guide plate is too big. You can divide it into 3 parts. It's more easier for you to put in mouth. And then we can generate a report to tell the patient why I will do this kind of operation. So during the operation, this is a local anesthetic operation. And then we need to do calibrate and the registration step by step. You see, 1, 2, 3, 4 in 5 minutes. And then we have a probe, we need to register the probe tip to use this probe to check the error. You see, suction device, tracking marker, and mouth opener. And then we use probe to check the error of the total system. After that, we drag the robot arm into the mouth, and then we drag it out. The robot will learn how to in and out automatically, and then the dentist only need to change drill, control the foot pedal. The robot can automatically go inside, drilling, water irrigating, suction with navigation. So maybe your operation always like one dentist with a nurse. Have you ever seen only one dentist operation? No. So the dentist now only need to change drill, control the foot pedal. The robot can help you to do accurate surgery. We also integrate a force sensor, which can feedback the force, because the bone density is not similar. So you see, the bone density force from different direction will be shown here. after each drill step, the hole have been. We can also can put the implant placement by robot. For each drill, we have planned the start point, end point. When this value changes to 0, it will stop and go back to start point. Finally, the implant placement. You see, also, when this value changes to 0, it will stop. Of course, fourth will feedback. We also develop a post-operative evaluation part, which can evaluate the accuracy of the operation in 1 minute. Originally, this evaluation part is used for me. I want to check our robot error. And now in China, a lot of dentists use this module as an evaluation for which can show to the patient, wow, our result is very good. So, you see, let's sum up. When a patient lack of teeth, a freshman can use the software to do planning and also design some accessories. And we also can ask an expert to check whether my planning is good or not. And then the dentist only need to change drill, control the pedal, and finish the operation. Because this is a local anesthetic operation, so if the head is moving, you see, it's me. The robot can also follow up. But someone think, wow, I will move like this. I said, this is a robot, not God, right? You should ask patient, do not move so fast. So let's breathe. So we can follow up, okay? And then for lifting sinus operation or some bone density is very big, we need to feedback the force. So you see, we can piercing when some bones are very hard. It's hard to pierce. The force will be very big. But if hollow, it's very dangerous. So during the robot operation, we have a force feedback, which can show you, you see, the force big, small. So an egg, we can piercing the eggshell without piercing the film and the liquid. This is an A4 paper on a balloon. We can piercing the A4 paper without damage the balloon. So in our robot, we have 4 ones. 1 CBCT scan for patient, 1 foot control, 1 dentist operation with 1 set of totally digital solution. So we also have AI engine, which can help you to segment all the tissues very fast. And this is our